In this example, I'm going to divide this polynomial by this linear binomial, and I'm going to do so using synthetic division. So remember, the biggest thing about synthetic division is this divisor needs to be written in the form x minus k. Well, it looks like this is x plus 5, so to write it in this form, it needs to be x minus a negative 5. So that means my k value is actually negative 5 right here to get going. So let's go ahead and write that negative 5 out front. And then let's do my bar for my synthetic algorithm. Okay, looking at this polynomial, it appears that I'm missing a couple of terms. So I have x to the 7th, x to the 6th, but I don't have my quintic term, x to the 5th, and I don't have my quadratic term, x squared. So I'm going to need to put zeros in their place as placeholders here, because it's important that we keep everything lined up by power. So the coefficient for x to the 7th, so 1, and then x to the 6th is 5, x to the 5th was 0, x to the 4th is negative 1, x cubed is negative 5, x squared is 0, x is negative 12, and my constant is negative 60. Kind of pretty tight on space there. And I'm going to put this bar here. This represents my remainder. So maybe there'll be one, and maybe there won't be. We'll see. So let's go through and run our process. So the first term here comes down, so 1. And then we're going to go through a process of multiplication, addition, multiplication, addition. So negative 5 times 1 is negative 5. When I add this column, I get 0. Negative 5 times 0 is 0. And I add this column, I get yet another 0. So negative 5 times 0 is 0. And adding this column, I get negative 1. This looks pretty easy so far. So negative 5 times negative 1 is positive 5. Adding this column gives me yet another 0. So negative 5 times 0 is 0, another 0. Negative 5 times 0 is 0. When I add them up, I get negative 12. And negative 5 times negative 12 is positive 60. And adding there gives me a 0 remainder. Alrighty. So to build this back up again, if this is my remainder and it's 0, this negative 12 is my constant. And then I have linear, quadratic, cubic, quartic, quintic, and sextic. So this x to the 6th will be the leading term. But we knew it was going to be x to the 6th because this polynomial was x to the 7th, and we were dividing it by a linear binomial, so I just take 1 from the power. Okay, so let's go ahead and write that quotient in full now. So I have 1 x to the 6th term, none of those, minus 1x cubed term, none of those and none of those, and then minus 12 with no remainder. So here is the quotient then when I divide this polynomial by my linear binomial x plus 5. And we did so using synthetic division.